Tuesday's quiz. Monday. It'll be a red calculator quiz. Because you can solve systems pretty easily if you kind of remember the shortcuts. And some of you comp sci people might know some of the shortcuts. We'll get there. We're not there yet. So we got to go old school with the TI-32X2S calculator. All right. You will have problems like this. You do need to know how to write infinite solutions as a general case, and then list 3 specific ones. Even if it says in terms of z, I don't care whether it's in terms of z or y or x, because in this one, I think z has probably been the hardest one because most of you eliminated z, and when you eliminate that variable, then it's hard to solve in terms of it. That would have made it a little bit tougher for those. Know how to get a quadratic function. Everybody should know how to find nickels, dimes, and quarters. Like that goes without saying. Now this is all matrices, and actually the first part, we'll get into how to solve them, systems with matrices, a couple different ways. We'll do one way in 9-1, and we kind of get into some properties of matrices. Comp sci people, you guys use matrices in coding, correct? All the time, because it's how you organize data. Okay, it's just the simplest way to organize data. The one thing you might struggle with is we don't have a row 0. I know. So when you're identifying specific spots, it's row 1, column 1. I know. Sorry about that. Okay. So like right here, now would you call that A00? Yes. Okay, got A11. So it's row 1, column 1. Rows go across, columns go down. And so you can have these. What's the biggest matrix you guys have used at any point? Okay. Could be anything. Right. When you're dealing with large volumes of data, you might have a large matrix. Yeah. That's the biggest matrix. We'll get this in. It's good just for me to highlight it now, but we'll get into some more in section I think 2. But like if you say I got a 2x3 matrix, call that the dimensions. Means you got 2 rows, 3 columns. And so 2 rows, 3 columns. So it might be 2, 3, -1, 0, 4, 8. These are typically going to be filled with a constant. So 2 rows, 3 vertical columns. The 4, okay, we would say that is position A22, second row, second column. That's a 4. First row, A13, third column. What would that be? First row, third column, that would be a -1. So if you want to talk about a specific constant, you got to be able to identify it. And so we identify with row and columns. And so we call it the ijth entry. The first I is your row. The J is your column. Okay, so we don't get into that a ton today. We get that into a little bit more. We're really going to use the matrices. And then this is basically a form of what's called linear algebra. If you progress into college, you can take a linear algebra course. It's almost all matrices, okay, when you're dealing with that. And just basically some of their uses and some of their properties. But we're going to take a system and we're going to put it in what's called an augmented matrix. You basically take the coefficients, 1, -1, -1, okay, and those become your constants of the matrix. 2, -3, 1, 1, 1, -2, and then you got your constant. So one thing you have to have it in order. You can't have, y plus x here. It has to be x plus y, x, y, and z in each case. You take your coefficients of x, your coefficients of y, your coefficients of z. Now, here's what we want. So you can go backwards. So if this is the matrix, then this is the equation x plus y minus 2z equals 0. Now, this isn't on your guided notes, but if I have a system like that, why is that maybe beneficial? If you take a look at that last row, what would that look like in terms of if I went backwards and wrote it as a system? Josh?
Z equals 1.
So you know Z equals 1. So if I know Z equals 1, then I can plug in Z here and figure out what Y is. And then I can plug in Z and Y and figure out what X is. This case where you get ones along the diagonal is going to be really important kind of as we move forward. So if I got ones along the diagonal, that's one Z, that's one Y, that's one X. And if I got zeros underneath, then I can solve it for that. So that's kind of be our goal, and I'll show you how we're going to get there. To get there, we use what's called elementary row operations. Here are the three things you're allowed to do. You can switch any two rows. Just flip them. Row 1 to row 2, row 2 to row 1. You can multiply any row by any non-zero constant. Okay, that you're going to change the values, including fractions. Those will come up. And then this is probably the one that gets used the most. The third one, when we're solving, you multiply a row and you add it to another row and you replace it. These are a little bit of our notation. You're going to need to be familiar with that. I'll show you how to do that. All right, so this first one, which should be underneath what you got there, right? All I want you to do, and this doesn't really lead to anything, it's just can you do the operations in order? So we're just going to use this, do those operations right on the bottom of that paper there. So for 1, and so now let me write down here. Row 2 is going to interchange with row 3. So all I want to do is rewrite those. So row 1 stays there. Move row 3 to where row 2 was. And then I make this -2, 4, 1, -5. Now, when you have a set of steps, you take the answer from step 1 and use it for step 2. Don't go back to the original one. Okay, so now this is the one we're going to work with. So for step 2, I'm going to take 2 times row 1 plus row 3, and that goes in for row 3. Row 3 will be the only row that is different. Okay, that would be the only row is different. So I got 1, -3, 5, 8. And now row 2 will still be the same. All right, now take 2 times row 2, add it to row 3, and you're better off working with the one above. So you don't get as things complicated. So 2 times 3 is 6. 6 minus 2 or plus -2 would be 4. And then take 2, everything times 2. So 2 times -2 is 4, or -4. -4 plus 4 is 0. 2 times 6 is 12. 12 plus 1 is 13. And then 2 times 12 is 24. Plus -5 is 19.
I'm lost.
You're lost?
We're doing row 1 or row 2.
Yeah, I thought it was 2 times row.
Oh, no wonder you're lost. So I wrote it down wrong. Or I wrote it down right. I did it wrong. You should be lost. All right, my fault. I was doing row 2. I should have been doing row 1. So erase that. All right, now take 2 times row 1, add it to row 3. So 2 times 2, 2 times 1 is 2 plus 3 gives me 5. Okay. 2 times row 1 is -6 plus. Oh, I did that wrong again.
Yeah.
I am not on my A game. Here's what I'm going to do. I'm resetting. Okay, resetting that whole thing. Okay. All right.
I got 11.
Okay, we'll pretend. All right, you flip row 2 and row 3. Everybody got that, right?
Yeah.
Okay, now I take 2 times row 1 plus row 3. That goes into row 3. Okay, so row 1 and row 2 will stay the same. And that's 3, negative 2, 6, 12. All right, 2 times row 1. 2 times 1 is 2 plus negative 2, 0. There we go. 2 times negative 3 is negative 6 plus 4, negative 2. 2 times 5 is 10 plus 1 is 11. And 2 times 8 is 16 plus negative 5 is 11. All right, now did I do it right? Thank you. So that is that second step, 2 times row 1 plus row 3. So you do not, even though we're multiplying row 1 by 2, you do not change it. Now the last step, use this answer to number 2. The last step is 3 times row 2. And so I got 1, negative 3, 5, 8. And then 3 times row 2, 3 times 3 is 9. 3 times negative 2 is negative 6. 3 times 6 is 18. And 3 times 12 is 36. 0, negative 2, 11, 11. Now, that's just to follow the steps. That's not leading us to the solution at this point. It's just making sure you can follow steps. You always go in order from step 1 to step 2. You use the answer from the previous one to get the next one. All right, flip it over in the back. This kind of gets into how we solve these using the matrices. Gaussian elimination, named for who?
Frederick Gauss?
Yeah, obviously. Frederick Gauss, one of the greatest mathematicians ever. Now, I think this whole page, I don't think there's really much you got to write. Just kind of paying attention here, explaining a couple things. So you take a system, you write it as an augmented matrix. Here's what our goal is. Our goal is to get it into row echelon form. If we get it into this form here, I can say z equals 3. I can plug 3 in for z, and I can figure out what y is and figure out what x is. So at that point, you can solve it. So that's good if we can get it in that form. Okay. Now in this next one here, we'll take a look at what's even better. So there's your augmented matrix. Row echelon form is here. That is good. But better is reduced row echelon form. Why is that even better? Okay, Aaron?
Usually you don't have to plug anything in, it just gives us the x, y, and z.
Yep, you got z is 3, y is 1, x is 5. Now those, I don't know why those are blue. That's not indicating anything crazy. But again, here's the key thing for all of these is we get 1s down the diagonal. Okay, so that's what you kind of want. So at this point here, z is 3, y is 1, x is 5. You're done. And really going from row echelon form to reduced row echelon form, it's just another step or two. It doesn't take a whole lot of work. Okay. Can you get the answer? Yes, that's good. This is better. Now, how do you do that? So here's kind of the steps. And in the end, to get to that reduced row echelon form, it's called Gauss-Jordan elimination. You always have to start with a 1 right here. Okay, once you start with that 1, here's kind of the steps that you need to follow. Get zeros underneath it. I'll show you how, but that's kind of the idea. Once you get this case here, then step 3, you want to get a 1 here. I don't care what's above or below it. You make that a 1. Once that's a 1, I make those zeros. So once I got row 1 and row 2, or column 1 and column 2 where I want it, I make this a 1. And then once that's a 1, I get zeros above it. And then that'll be my answer, answer, answer. All right, let's take a look at an example. It's not going to make a whole lot of sense till we do one. I take that, write it in an augmented matrix. Now, part of this, what you need to do is you need to write down each step what you're doing, kind of like those row operations, because otherwise, then I have no idea what's going on, or nobody has an idea. So this is 1, -3, -3, 4. 4, 1, 1, 3, 2, 1, -1, 7. First step, we want to have a 1 in the top left corner. Do we have it? Okay, so that's good. Usually what happens is you can just interchange rows or multiply by a constant. Okay, if you don't have it. All right, now what's our next goal? We want this 4 to be a what? And we want this 2 to be a 0. To get zeros, you have to add things. Well, what do you have to add to 4 to make it 0? So you got to add rows together. We don't have another -4, so you've got to multiply a row to get the -4. And it's going to be easiest to work with the 1 that is in that column. So I'm going to take -4 times row 1 plus row 2, and then it's going to substitute in for row 2. And do me a favor, we're going to do 2 steps in 1 here. Do not write row 3 down yet. So just don't get too far ahead of me. Row 1 will not change. Row 1 stays the same. So you got 1, -3, -3, 4. Okay, what this says, I'm substituting for row 2. That means that row 2 is going to become different. -4 times row 1. Well, -4 times 1 is -4. Plus 4 gives me 0. At this point, you cannot worry about anything else. Like, don't try to do 2 things at once. Just because things will change. As long as that's a 0, you're good. Multiply the rest of the row by -4. Add it to row 2. What's -4 times -3? 12 plus 1. 13. -4 times -3. 12 plus 1. 13. -4 times 4. -16 plus 3. -13. Now, you can do one step at a time, but in this case here, when I'm making like the zeros, I'm going to do them both at the same time just to save a little bit of room. I got that 0. I want this 2 to be a 0. Okay, what do you think you do? Same concept. Multiply row 1 by, instead of, and you can multiply row 1 by different numbers each time. So I'm going to multiply it by -2. So -2 times row 1 plus row 3 will go in for row 3. All right, if you think you know what you're doing, write it down. If you're not quite sure, just wait a minute. But you need to tell me exactly what you're doing with these operation steps. So right now, if I look at that, I say, all right, you're taking -2 times row 1 plus row 3. Plugging it back in for row 3. Well, -2 times 1 is -2 plus 2, 0. That's a 0. -2 times -3. Watch your signs. That's a 6. 6 plus 1, 7. -2 times -3, 6. 6 plus -1 is 5. -2 times 4 is -8. -8 plus 7 is -1. Sometimes you get other good things happen. Sometimes you don't. But right now, the only thing you want to concentrate on is, do you have a 1, 0, 0 in the first column? Yes. What do we say you have to get next?
0, 1, 0.
Yeah, but they got to go in a certain order.
0, 1.
We got to make this right here a 1. When you're making things 0, you add. When you're making things a 1, you multiply. What times 13 gives you 1? 1 over 13. So I'm going to take 1 over 13 times, 1 over 13 times row 2. You really don't want to try and add, like some people say, well, if I multiply this by 4 and add it, That'll give me a 1, but it's going to change your 0. So usually adding will change your 0. Multiplying, you multiply the 0 by 1/13, that changes it. So 1/13 times row 2. Row 1 stays the same. I get 0, 1, 1, negative 1. 0, 7, 5, negative 1. Can you get fractions in this? Yes, but you hope you don't. And if things starts looking too crazy, you probably made a mistake. All right, we made that a 1. Now what's our next goal? 0 is above and below it. 0 is above and below it. Now we're gonna do similar things. Now if you are, here's what you want to do, it will help the most, is when you're working with column 2, use row 2. So multiply this by a constant and then add it to row 1 and then add it to row 3. Well, what constant do I need it to by to make this negative 3 a 0? Multiply row 2 by 3. So take 3 times row 2 plus row 1. And that goes in for row 1. Okay, I'm going to write row 2 down because that's not going to change. All right, what do I get? 3 times 0. See, this will not affect this 1. 3 times 0 is 0, plus 1 is 1. You're still following the operations, so it's not going to affect it. 3 times 1 is 3, plus negative 3 is 0. 3 times 1 is 3, plus negative 3 gives me another 0. Sometimes that third 0 will change, sometimes it'll stay the same. 3 times negative 1 is negative 3, plus 4 is 1. All right, how do I make that 7 a 0? Negative 7 times row 2 plus row 3 in for row 3. Oh, here, Ashley.
There it is.
Cooper.
Yeah, I know.
There you go. What do we got for lunch today?
Well, probably a sandwich, probably some chips, maybe some apples.
Okay.
I'm sure it's good and healthy. Oh, yeah. Thank you.
All right, negative 7 times row 2. That still keeps this a 0 because that's important. We don't want to change anything back. So that's why if we follow these steps, the columns will stay the same. Negative 7 times 1 is negative 7 plus 7 is 0. Negative 7 plus 5 is negative 2. Negative 7 times negative 1 is 7. Minus 1 looks like it gives me a 6. Okay, you have column 1, just like you want it. You got column 2, just like you want it. Now work down the diagonal. Don't worry about anything else. You got to make sure that bottom one is a 1. And when you want to make a 1, you multiply. So what are we going to multiply that by? Negative 1/2. So take negative 1/2. Negative 1/2 times row 3. And so that's going to give me, nothing else changes. That gives me 1, and then that'll give me a negative 3. All right, the first row looks good. It's actually not going to change. I got my 0 there. Only last thing I got to do is make this 1 right above there a 0, and I'll be done. Could I get the answer from here? Yes, you could get the answer, but it does say take it all the way down to reduced row echelon form. So I got to get rid of that 1. And how do I do that? What would be the easiest way to do that? Cooper?
Negative R3 plus R2, and replace R2.
Yep, negative R3, or just think about it, you're multiplying by negative 1, which is the same thing, plus R2, row 2, in for row 2. And so that's going to be, hold on here. And that gives me 0, 1, 0. All right, what's that very last one there gonna be then? 2. And now we're done. Because you got x equals 1. You got y equals 2. You got z equals -3. And please make sure that you understand that you can take those and plug them back into the original equations and make sure they all work. Bless you. Okay. All right, I want to do another one on the back there. All right.
Oh,
Copy that down and then write the augmented matrix. Do it all the way in the back. Then I'll sketch up.
you can probably. No, I'm saying,
I missed my line. I have OCD. Do you want to know OCD? Or this I can I just know this. I got it in school. What exactly? Like, oh, I've been for a long time.
All right, now it's just a little bit easier for the first couple times is make sure that first one's a 1, so you don't have to mess with that. So you already got a 1 there. Think columns. So underneath that, you got to get a 0 where the -2 is. We got to get a 0 where the 3 is. So I'm going to do both those kind of in the same step. How do I make the -2 a 0? You think add. You add 2 plus -2 is 0. So multiply row 1 by 2. 2 times row 1 plus row 2. And we replace row 2. And then I'll do that first and then I'll look at row 3. So row 1 is not going to change. 1, 1, 1, 4. So I get 2 times 1 is 2 plus -2 is 0. And you really can't worry about anything else. Like don't. Every now and then, like two good things will happen in one move, but don't try and sit there and figure it out. Just do one at a time. 2 times 1 is 2 plus 3 is 5. 2 times 1 is 2 plus -2 is 0. 2 times 4 is 8 plus -23, -15. All right, Mackenzie, you got this figured out yet?
Kind of.
What do you think we do to get rid of the 3?
Multiply row 1 by -3
Okay,
and then add row 3.
good. So take -3 times row 1 plus row 3, add it in row 3. So that gives me -3 plus 3, which is 0. -3 plus -2 is -5. -3 plus 4 is 1. -3 times 4 is -12, positive 20. So we got the first column. Things are looking good. All right, what do you need to do next, Mia? You know?
The 5 of them.
Yep, make this 5 right there in the middle a 1. And how can I do that, Mia? So if you add row 3, it'll give you a 0.
Oh, yeah.
When you want to make things a 1, think multiply. What times 5 gives you 1? 1/5. Because by multiplying, you're not really going to change anything else. Because when you add, a lot of times you never want to make either of these zeros another number. So I'm going to multiply by 1/5 times row 2. And what do I got? I got 1, 1, 1, 4. I got 0, 1, 0, -3. And I got 0, -5, 1, 20. Now you want to make the number above this 1 in the middle a 0, and then this -5 a 0. So this 1 and this -5 need to be zeros. I'm going to use row 2 to multiply and then add. So -1 times row 2, or just negative row 2, plus row 1, replace into row 1. And let's see here. Row 2 is going to stay the same. That still stays a 1, because it's -2 times 0 plus 1 still stays a 1. But -1 plus 1 is 0. That still stays a 1. And then it looks like I get what, a 7? Am I good there? All right. What do I get now? Get rid of that bottom -5. So take 5 times row 2 plus row 3 in for row 3. All right. See what you get there. Okay. All right. Adam Lippy, what'd you get for that bottom row there?
0, 0, 1.
And then how about over here?
5.
5. So we took 5. Okay. All right. So that's already a 1. So that worked out really good. So I can make that a 1. And then the last thing I got to do is make the 1 in row 1 a 0. And then you can take negative row 3 plus row 1 back in for row 1. So that still stays 1, 0, 0, and then negative, that becomes -5 plus 7 is 2. 0, 1, 0, -3, 0, 0, 1, 5. All right, so we're good. Once you got that, 1's down the diagonal, 0's everywhere else. X is 2, Y is -3, and Z is 5. Oh, that's a positive 5. So 2, -3, 5. Okay. 29 through 32 are just following the steps. 73 is the only one where you gotta do the whole thing. Okay. 29, you just gotta go give you like 3 things to do. Do those. 73 is the only one, like I said, we're gonna do the whole ball of wax.